by the different enzyme, it's converted to the 3-carbon carbohydrate, and finally the end product was pyruvate. And as I mentioned, the production of pyruvate is in the presence of oxygen. So glucose pyruvate as actually considered as an aerobic glycolysis, as you can see here. This is the aerobic glycolysis. But in a fermentation, in a lack of mitochondria, in a lack of oxygen, and in some actual part of the eye, for example, lens, cornea, in some part of the kidney, testes, leukocyte are missing because they are poorly vascularized and they don't have mitochondria. Pyruvate is not end product. The end product is lactate. Okay? The end product is lactate. But you should know that from glucose to pyruvate, we produce 2 NAD. You know why? Glucose, one glucose continuum, it converts to the 3-carbon. Am I right?
Yes.
Glyceraldehyde. They continue the pathway. to the pyruvate. And again, pyruvate. Okay? During this reaction, for each reaction, you have NADH and also here production of NADH. For this reason, I wrote it 2. Clear? You understand why we wrote 2? Because 1 glucose convert to 3-glyceraldehyde 3-phosphate and they continue the pathway. Actually, we wrote it. And finally, they reach the pyruvate. But whenever you want to, in a situation of the anaerobic metabolism, you use these NADH. As you can see here, 2 NADH consumed for conversion of pyruvate to lactate. Do you understand? Or no? Okay, repeat. No. In an aerobic glycolysis, this one. It's better to have it with you. In an aerobic, 1 glucose. Glucose, how many carbon present? 6. Continue the pathway, and finally you have it 2, 3-carbon sugar. One of them is glyceraldehyde, another one is dihydroxyacetone phosphate. Up to here, it's okay? Do you understand? After that, if I continue the procedure, the second step, now we have a 2 glyceraldehyde, okay? Can you imagine? 2 glyceraldehyde. So, 2 NADH because 2 glyceraldehyde is present, 2 NADH at this step. 2 ATP from the kinase activity here. 2 ATP from the pyruvate kinase activity here. Clear? Do you understand? What about this one? Should I multiply 2?
No.
No. Okay? So, for the first 5, only 1 reaction, 1 series, because 6 carbon, 6 carbon, 6 carbon, up to here. Only 1 ATP, 1 ATP. So, from 1 glucose, I want to review the energy requirement. For 1 glucose, for the first 5 reaction, how many ATP required? 2. You understand? 2. What about the second phase? How many ATP? Please do not pay attention to NADH. 4. Here we have it for ATP produced. When I represent by the positive, it means that produce. Okay? But in a previous slide, I I show how many ATP consumed? 2. So it means that negative 2 ATP. I wrote the amount of the ATP in a total 10 reaction. Okay, how many NADH is produced? 2. Plus 2 NADH. How many ATP produced from 1 NADH? 3. I will tell you how. So 2 times 3. How many ATP here? 4, in other words, plus 6 ATP. So what is the net production? 8. So you can actually, we have it, I wrote it here, minus 2 here, plus 4 here, plus 6. What is the net? Plus 8. Do you understand? Yes? So please pay attention, never times the multiply 2 in the first step. Glucose, fructose 1 and 6 phosphate. Okay, these are 6 carbons. But after the first step, you should multiply 2 as I wrote here. 2. Because 2 glycer of like enter this pathway. Okay? Do you understand completely? Okay, this is the energy, but please pay attention. When you have a pyruvate. Okay? When you have a pyruvate. When you have a pyruvate, it means that this is aerobic. It means that oxygen is present here. Okay, oxygen is present. But what about the lack of oxygen or anaerobic? After this reaction, pyruvate convert to the lactate. Okay, I want to show you, I want to compare this one. Okay, in anaerobic reaction. Okay, for anaerobic, pyruvate convert to lactate. What is the requirement here? How many pyruvate do you have? At least you have actually, at the end you have 2 pyruvates. So for each pyruvate, 1 NADH is required and convert to the NAD plus. So generally, because for 1 pyruvate, for one pyruvate, 1 NAD required. For 2 pyruvates, 2 NAD required. Okay? So please help me. What is here? Whenever you have it anaerobic, so you should add it minus 2 NADH. Why? Because you consume here. You should consider this. To produce, to consume. It means that 0. Okay? So you should consider this one. What is the remaining? Plus 4 minus 2. Minus 2 plus 4. What is the net in anaerobic? Plus 2 ATP. Do you understand how we can calculate this one? So, I want to review my example question. How many ATP totally? Please consider NADH also. How many ATP consumed from 1 pyruvate, 1 glucose to pyruvate? How many, produce? How many ATP produced from 1 glucose to pyruvate?
8.
How many ATP produced from glucose to lactate?
2.
Maybe I ask this question in an anaerobic situation. I didn't give you the name of the lactate. Okay? Maybe I ask you in an aerobic situation, how many ATP produced?
2.
Aerobic oxygen.
8.
In an anaerobic, 2. Okay? So how Anaerobic. So for anaerobic, end product is lactate. Okay? For the conversion of pyruvate to lactate, I have to spend 2 energy. I have to spend my cash. Now my cash is not ATP, it's NADH. Okay? So you use your NADH that produce here. So you cannot consider it as a source of energy because you have to use it. Okay? For example, during the glycolysis, I earn them, for example, these are 2 NADH, and I put in my pocket. Okay? I enrich the pyruvate. Okay? At this stage, it told me, for example, you want to convert to lactate, at first give me 2 NADH, okay? Give NADH and turn to the lactate. Is there any NADH here? No, because I spent it like the money. Okay? So you cannot consider as a source of energy. You have only 4 ATP, 1, 2, 3, 4, and you use the 2 ATP in the previous first 5 reaction. So the subtract of 4 from 2 is net production is 2. Clear? Do you understand? Negative means that you spend. Positive means that you earn it. Inshallah, all the time you have a positive. As a review, it is actually lactic. About the localization, the localization also is important. You should know that each metabolic pathway takes place where? Cytoplasm or mitochondria. In each cell, okay? So, if I ask you, what is the localization of the glycolysis? It is inside the mitochondria or cytosol? Cytosol. What about the Krebs cycle? Mitochondria. What about the what is the input? Glucose. What about the output? Maybe I ask you. The output is depend on the presence of oxygen. In an aerobic, what is output? How many ATP produced? 8. In an absence of oxygen, or maybe I didn't tell you lactate, absent. Maybe I ask you in RBC. Okay? RBC, actually because it's lack of mitochondria, all the time it is anaerobic. So, what is the output of glycolysis in RBC? 2. What is the name of the compound as an output? Lactate. Okay? This is a review, as I mentioned. 2 ATP you spend. Gaining 4 ATP and 2 NADH. And by this way you can calculate the aerobic glycolysis. This is it overview. What about the regulation? Please tell me. What was the name of the regulatory enzyme? So these are 3 irreversible. Okay, again, one direction. This is not reversible. Just one direction of reaction of the glycolysis. So if you want to control this pathway, you should control this enzyme. But as I mentioned, if I want to choose one of them, which one is the most important? Phosphofructokinase, because phosphofructokinase produce the highest energy molecule. I mean fructose 1 and 6-phosphate. You remember this compound? This one. Fructose 1 and 6-phosphate contain a large amount of energy. So this enzyme should be tightly regulated, okay? Who was the regulator, as I mentioned? This is not actually, I think, difficult to memorize. What is AMP? I'm hungry. So when I'm in a hungry mood, glycolysis should be active? Yes, because I need energy. But what about ATP, I full inhibitor, okay, as you can see here. And also, do you remember feedback inhibition? What was the feedback inhibition? Inhibition of enzyme by the product. Okay? All the time. For example, in a Krebs cycle, we have this kind of control. Fructose, when we say, for example, fructose 1 and 6-phosphate is high, what does it mean? It means that I'm here. Please suppress your reaction. Why do you want to waste your time, to waste your energy? Everything is okay. Okay? So it's considered as an inhibitor.
Sorry, the most important is later.
Insulin?
Fructose 2 to 6 is phosphate.
I will review, I think, in the next session. Okay? Because some of their reactions are very similar glycolysis to the gluconeogenesis. I put it on that slide, okay? I will, don't worry. I never miss any important point. As you can see here, this is an overview of glycolysis. You can consider this point. One glucose, 6-phosphate, one fructose 6-phosphate, one fructose 1 and 6-phosphate, and 2. Finally, 2. So you have it 2. Clear? Okay? Because we repeat this one. So for calculation, we should multiply the energy of ATP into 2. This is a molecule, important molecule, and the most powerful compound inside the glycolysis. This is the one, and actually not most powerful. Actually, it is some properties is important. Okay, it's not important to make a mistake with the other points. So I prefer to visit. Just know that a powerful molecule that produces ATP in the, maybe I'll ask you, what are the substrates for the production of ATP in the glycolysis pathway? What are them? 1 and 3 biphosphodiesterase can produce the ATP. And another substrate is phosphoenolpyruvate. So these are high energy molecules that produces ATP. And now the regulatory reaction goes by different arrow color. And as I mentioned, the most important is phosphofructose kinase. I repeat this one because I want to memorize it right now. Okay? One of the important pathways that happen inside the RBC. At first, I want to recall some point from the previous semester. Do you remember the different structure of hemoglobin? R and T. R for happy. What high affinity for oxygen? Do you remember? In a lung, after respiration, the pressure of oxygen was very high, okay? And all of the oxygen bind to the hemoglobin, so you have an R form. R form has a high affinity and never releases its oxygen, okay? What about the T form? Do you remember? The salt bridge form. Do you remember the salt bridge? What is salt bridge? You can tell me. Salt bridge. This is the kind of bond between positive and negative atoms, okay? In a T form, why it has a closed structure? Because, for example, my left hand is negative and my right hand is positive. They attract each other, okay? And now I'm in a T form. What is my affinity to oxygen? No, I didn't want it. So I release oxygen. So whenever, if you remember, recall that, whenever you require oxygen, okay? Whenever you require oxygen, the form of the hemoglobin is T. And if you remember, one of the regulatory molecules was 2 and 3 bis phosphoglycerate in a curve of the oxygen saturation curve. You remember? I'm sure no. Okay? I won't just pass the biochemistry, okay? What is biochemistry? If you remember, I told my family when I got to the class, at the end, I told him, Ya Allah, what is biochemistry? But you know, biochemistry requires more study compared to other courses. Okay? To be honest, it's not very difficult. Oh, and really. You should study more, actually. And inshallah, I will actually ask you some simplest questions, and all of them will review during my class, okay? Inshallah. For my part. I'm not sure.
حتى القلم وجع ما تحمل.
You make it possible, Dr. Fanoni, and Allah show me this is Please pay attention. As I mentioned, whenever, please pay attention, whenever you have it 2 and 3 bis phosphoglycerate, what is the charge of this molecule? What do you think? What is the charge of this molecule? 2 and 3 phosphor. Negative. It's full of negative charge. Okay? Whenever you have this negative molecule bind to hemoglobin. For example, this is -1 and this phosphoglycerate. Make it positive, actually, make some salt ring with a positive ion, and it can cause the change of the structure of hemoglobin to the T form. So, when you have a high of this molecule, what is the form of hemoglobin? T. Right? T means that low affinity. Affinity for oxygen. Okay? It means that low affinity for oxygen. It means that the hemoglobin, this is the T form of hemoglobin, releases oxygen very easily. Whenever you have, for example, a requirement for the oxygen can release from hemoglobin and deliver it to the other tissues. How? By the Rappaport shunt. What is Rappaport shunt? It is actually one other pathway inside the glycolysis. This is a glycolysis. Glucose, glyceraldehyde, up to pyruvate. Whenever you are in a high altitude, in a mountain, okay, you are at a risk of hypoxia. It means that the level of oxygen is very low. So instead of convert to the 1 and 3 to 3 phosphoglycerate, it's make it terrain. Why? Because it wants to produce it 2 and 3 biphosphoglycerate by the help of, maybe I ask you about the name of the enzyme in a Rappaport shunt. The name of the enzyme is Rappaport shunt is important. One of these phosphoglycerate mutase. What is mutase? Because it changed position 1 to position 2. It is kind of isomerase. As you can see here, this is 1 and 3, this is 2 and 3. Okay? And after that, you have a phosphatase. What does it mean, phosphatase? You take phosphate. So remembering these 2 enzymes is important. Maybe I didn't ask you about the raw proportion. Maybe I asked you, you are in a high altitude, okay? You are in a position of low oxygen. Which shunt of glycogenolysis is active? What is the name of the shunt? Shunt means pathway, okay? Shunt means pathway. What is the name of the pathway is active? Rapoport. What are two major enzymes? Mutase and phosphatase, okay? And finally, this molecule again enters to the glycolysis and by the conversion of pyruvate can produce the ATP. Clear? Yes? If you remember, I mentioned this point at the beginning of the slide. No matter you take a glucose, galactose, or fructose, all of them should be converted to the glucose, or all of them actually should enter to the glycolysis pathway. What about fructose? If you take a fruit, because fruits are full of fructose, it depends on a site. In the liver, you should remember the name of the enzyme. Maybe I ask you, what is the enzyme responsible for the catabolism of fructose in the liver to convert the fructose to fructose 1-phosphate. This is a fructokinase. When we say hexokinase, it means that a 6-carbon carbohydrate added phosphate, no matter. This is a glucose. You know, all of them. Please pay attention to the site. When you have a hexokinase, glucose convert to the glucose 6-phosphate. When you have a fructose, hexokinase convert fructose to fructose 6. All of the hexokinase add at the position of 6. Okay? Never tell me fructose 1-phosphate. We require another enzyme. So hexokinase just at the position of 6 in a skeletal muscle, for example. But in a liver, we have another kinase. The name is fructokinase. Added fructose 1-phosphate, and by although there is now dihydroxyacetone present and glycerolide present, it is different. We require one more phosphate, as you can see here, to convert the glycerolide to phosphate to continue the glycolysis. And about galactose, what happens? For example, you drink a meal, okay? Galactose and first convert to the 1-phosphate form, and by the several, about 5 reaction, glucose 1-phosphate is produced. Can glucose phosphate directly enter to the glycolysis? No. Why? Because this is 1. It should convert to 6 and then continue the glycolysis. This is the entry of carbohydrate to the glycolysis. About the pyruvate kinase, I mentioned this one to the other group. I take one of your questions would be from this enzyme. Because this enzyme is very, very, very important. Because why? Because this is the link between glycolysis and Krebs cycle. Okay? The linker between glycolysis. If I ask you, what is the name of the enzyme that link glycolysis to Krebs cycle? It is a pyruvate dehydrogenase, and sometimes known as a pyruvate decarboxylase. But you should know that I'm talking about this complex, pyruvate dehydrogenase. But you should know that if I ask you about the fate of pyruvate, do you know what's the meaning of fate?
The end.
سرنوشت. سرنوشت چی میشه؟ فیت رو چی میگی؟ فیت میشه چی؟ مسیر؟ About the different fate of the pyruvate, maybe I ask you about this point. Sometimes, inshallah, in amino acid catabolism, I will tell you about the conversion of pyruvate to alanine. About pyruvate, what is it? Pyruvate to lactate.
The lactate dehydrogenase.
lactate dehydrogenase. Where we have this point? This reaction?
Anaerobic.
Anaerobic. Okay? So in anaerobic, lactate dehydrogenase is active. But if you want to enter to the Krebs cycle, pyruvate convert to the oxaloacetate. But in a, for example, other way, you will enter to the acetyl way. Or, sorry, this is more important, especially for the gluconeogenesis. Okay, in the next session, I will review this reaction. But as I mentioned, this reaction is very important because it set the stage and provided background for the link between glycolysis and Krebs cycle. What is localization? This is inside the mitochondria. What is the input? Pyruvate. What is the output? How many carbon present in pyruvate? Three. Remember, glycolysis converts 6 carbon finally to 2 pyruvate. Am I right? So this is the 6 carbon, these are 3 carbon. You remember? Okay, what about acetyl? Well, how many carbons? 2. So for this reaction, you have the release of CO2. Yes, Asan. When you release the CO2 or carbon dioxide, it means that decarboxylation. And what is the energy output? 1 NADH produced or 3 ATP produced. This is the conversion of pyruvate to acetyl way. As I mentioned, this is the link between glycolysis, Krebs cycle. What is important, very important, the requirement, coenzyme NAD, please pay attention, plus, not H, thiamine pyrophosphate, FAD, and liquid. Maybe I ask about the requirement. If in a list of requirement, I put NADH, it is correct or not? NADH.
No.
NADH is required? No. NADH produced. Who is required? NAD plus. Okay? Please pay attention to this point. And thiamine pyrophosphate, what is thiamine? B1. And liquid is another factor. FAD is actually derived from vitamin B2. And what is the net energy product? 1 NADH, considered as a 3 ATP. But you should know that the pyruvate dehydrogenase is a large molecule. It is a complex with the different parts, E1, enzyme 2, enzyme 3. You know, the process is very, very complicated. For example, at first you have the decarboxylation, after that esterification. What does it mean, esterification? Do you know what does it mean? It means that when you add, for example, one ester, okay? For example, if you added coenzyme A to this part, you attach coenzyme to this part. What is it? Acetyl. AC is abbreviation of, actually, sometimes you have this expression. AC-CoA. What does it mean?
Acetyl-CoA.
Acetyl-CoA, okay? So after adding acetyl to coenzyme A, this is now as an esterification and reduction of NAD plus convert to the NADH. Okay? As you can see here, each part have a specific function. One of them responsible for decarboxylation. One of them responsible for esterification. Another one for reduction. Okay? This is a very, very complex molecule. And please pay attention, pay attention. Glycolysis happens inside the cytosol or cytoplasm. But about pyruvate dehydrogenase inside the mitochondria. So we should send pyruvate by some transporter by number inside the mitochondria. Inside the mitochondria usual pyruvate convert to the